Yo, KSP, solubility equilibria. Most important thing is understanding what the net ionic equation is, so then you can plug it in to do the problems that you did for homework. All right? You weren't too complicated of a math system, but if you don't know how to break it into ions and so forth, you won't know how to square it, cube root it, or whatever you need to do. All right. Many important ionic compounds are only slightly soluble in water, and equations are to be written to represent the equilibrium between the compound and the ions that it represents. All right, the solubility product constant KSP, it was a bear last year on the AP exam, so I'm not expecting a huge chunk of it on this year's exam. It was a bear. I mean, it killed people last year. Why do I know? Because we covered it for half a day, and then people got killed on it. So we'll spend hopefully today, and we'll be good to go on it. All right, and I know a couple schools didn't even get to it. All right, is the product of concentration of ions involved in a solubility equilibrium, each raised to a power equal to the stoichiometric coefficient of that ion? Okay, so let's take a look at these two. All right, so on your paper, I went ahead and wrote out what your KSP should look like. So if you're getting a value for it, you either get it in a table or given to you in the problem. And KSP is the concentration of Ca2 plus times the concentration of fluoride squared, because you have to break it up into its ions, and the KSP value is 5.3 times 10 to the negative 9. For the next one, I have it written down for you as well. We're going to do KSP as the concentration of As to the 3 plus. All right, what's As? Arsenic. Is it poisonous? Yes. Where do you use it? Rat poison. Good. Hey, at least you know something. All right. And times the concentration of sulfide to the third. Does that make sense? Is that pretty easy? See how that works? Yes? Okay, good. I put little colors on there to make it easier for you. Remember, solids are not in the equilibrium expression, so you might want to highlight that. It will screw you up later if you forget that. All right, solids are not in those expressions. All right. So you'll have a chart either given to you, provided, or it will be given to you in the problem what the KSP value is. Does any of these kind of look strange to you, or did we just do something like this? Thank you. All right, what's C2O4? Calcium oxalate. Very good. Very good. Just see if I can pick any out here. All right, every other one should be good. Oh, here you go. Anybody lose the ear, Cheryl? You need that. If I would have rung that, that would have been like ultimate. All right. All right. So very good. So you know all those. Not a problem. All right. The solubility product. Constant KSP is related to the solubility of an ionic solute, but KSP and molar solubility, the molarity of a solute in a saturated solution, saturated aqueous solution, KSP and molar solubility are not the same thing. Calculating solubility equilibria fall into two categories: determining the value of KSP from experimental data, or calculating the equilibrium concentrations when KSP is known. Yes? The liquids, we will be using some, but not for ones you probably have to calculate if you did on AP. Okay? We will be doing a couple. All right? All right, so here we go. Calculating KSP. It is found that 1.2 times 10 to the negative third mole of lead-2 iodide, PbI2, dissolves in 1 liter of aqueous solution at 25 degrees. What is the KSP at this temperature? All right, so what's the first thing I'm going to need to do here? Let me get a good color while you're thinking. All right, so from this part, what you did for homework, I'm going to have PbI2, and what am I going to have? I'm going to go back and forth. What am I going to have? Euler. Pb2 plus 2I minus. Okay. Well, that's great. What's the KSP going to be? Yeah. Concentration of lead 2 times. Okay, so we have that. Everybody agree with that? Okay, now we need to figure out what the KSP value is. All right, we need to figure out what the KSP value is. So KSP, you guys did some of these for homework. All right, what would I put in here? All right, what about for the iodide? 2 times. All right, so I'm going to do this. 2 times 1.2 times 10 to the negative third squared. All right, see if you can get an answer. See if you can get an answer. It's not hard math, but we need to cover it for a little bit of time. What?
I told him to it's kind of like this. So it's like plus that plus 2x.
Mm-hmm.
If you want to do that.
Can't do that. Anybody have an answer? 6.9 times 10 to the negative 9. Everybody get that? That Brocklenberger? Got it. All right, moving on, moving on. 3, 2, 1. All right, good. Calculate the molar solubility of silver chromate, Ag2CrO4 in water, from KSP equals 1.1 times 10 to the negative 12 for Ag2CrO4. Silver chromate. All right, what's the first thing you need to do here, Melissa? Okay, very good. All right, very good. All right, so I'll just do this because I want to build off what Chrissy said. What do I got here? Okay, so we got a 2x and we have an x. All right, because we don't have anything else at this point, what would we have to do next? KSP equals what? Well, we're not there yet. We need to write our original equation.
2x squared.
Not there yet. Ag plus squared times CrO4 2 minus. Okay? Now, we know what KSP is. Equals what? All right. Now make sure you do the 2x squared and the x is in the right spot, because 2x squared all in the same thing is not what that is. What is that? 4x squared is different than 2x squared. Got to make sure that's the other kind of little thing. It's not hard math, but it is something that you should be able to accumulate a lot of points on that I know a lot of kids did not last year. All right, so what do we get? 1.1 times 10 to the negative 12 equals what? 4x cubed. All right. All right, what does x equal? Command 6.5 times 10 to the negative fifth. Now I'll ask you, am I done? Am I done? Am I done? No. Why not? CrO4 2 minus equals what? 6.5 times 10 to the negative fifth molar. And I'm going to go ahead and do this. What about Ag plus? What do I have to do to find the molarity? 2 times 6.5 times 10 to the negative fifth. And that is going to equal what? What'd you get?
1.3 times 10 to the
Negative fifth or fourth?
4.
Okay. Okay, you understand? You got to bring it back just like we did in equilibrium problems and fill those x's back in. All right? Any questions on that? Okay, very good. Question? We got to wait. I heard a wait. Okay, we're moving. Moving slowly. Probably neater than what I did, right? All right, common ion effect. Also affects solubility equilibria. Le Chatelier's principle is followed for the shift in concentration of products and reactant upon more addition of either products or more reactants to a solution. The solubility of a slightly soluble ionic compound is lowered when a second solute that first is a common ion is added to the solution. That's a multiple choice question all day on AP. Any of these things, especially that second point, could be asked in many different ways on the AP exam for multiple choice. Remember, you have 75 multiple choice questions. You have to get as many as you can. Pretty much you know what your averages may need to be. Okay. What is the solubility of silver chromate in a 0.10 molar solution of potassium chromate? All right, so take a look. What happens here? So my normal KSP value for silver chromate is 1.1 times 10 to the negative 12. Now, what did I add to it? What got added to the silver chromate? Okay, potassium chromate, but what's the most important part of it? All right, the chromate is added to it. Based on the last slide, what should happen? All right, very good. What happens? Take a look at the comparison of solubilities. 6.5 times 10 to the negative 6 in 0.1, 1.7 times 10 to the negative 6. What happened to the two numbers? The solubility lowered. All right, that's the common ion effect. So you need to look, if this is added to it, this number must lower. All right, did you get this from your reading? Yes, no, maybe? Adding more chromate, ion shifts equilibrium back to the reactants, which is solid silver chromate. All right. So, that means we have to do a problem. What is the molar solubility of calcium fluoride with a KSP of 4.1 times 10 to the negative 11 in a 0.025 molar solution of sodium fluoride? All right, so let's go ahead and do some work here. Let's do some work. What do you guys have on your chart? All right, so let's do a formula. Any formulas that we could do? Any equations? Anything like that? What do you think? All right, so CaF2 is going to be what? Ooh, I was almost Fe plus 2F minus. Kind of like my grade. All right. Okay, and the KSP then is going to be what? I think I put it over here. KSP is what? Yeah, you know you're going to have a 2 in there when it comes. All right. You can put the 2 in there if you want. It's technically not correct. Do that. All right. So before it dissolves, what do we have? How much Ca do we have before it dissolves? Ca2 plus. How much of that do we have? How much calcium do we have, Ca2 plus, before it dissolves? I'm hearing it. No? Okay. All right, so we have none of that before it dissolves. How much F minus do we have before it dissolves? All right? Okay, are there any questions so far? All right, so after it dissolves, all right, after it dissolves, what am I going to get for Ca2 plus? Do we know what we're going to have here? What will we do for that? It'd be X, right? X. You can do plus X if you want, that's fine. X. And what about F minus? What's it going to be? All right, 0.025 plus 2x. Let's talk about where they came from. Where did this point come from? Don't you have an arrow there? Where did it come from? What?
E solution from the
Which one? Which is?
which is 20.
NAF. Where did this one come from? CA F2. All right, so far that's what we have. All right, not a problem. Now all we have to do is solve. All right, so we're going to solve here. All right, anybody know a KSP value? 4.0 times 10 to the negative 11 is going to be, remember, we're going to plug it back into this guy over here. All right, going to plug it back into that. So what are we going to have? X times minus 2x squared. Oh, good.
You're adding.
Let me work it out both ways. Try plus 2x first. Can't do that in my head that quickly. I'm not sure what. Sorry, I was trying, but I couldn't. All right, try it with that first. Won't matter. Doesn't matter. Either one. Top? What'd you get?
I don't.
Oh, that probably will be hard to do without a calculator. I did it preliminary in my head and I said it doesn't really matter if I have plus or minus two of these. I know that for sure. Chris?
I'm still.
Oh. Okay, here we go. Oh, what are you guys using? What are you trying to do? Are you trying to use a quadratic?
Yeah, we should.
No.
Just take out.
So talk to me. Why are you not using a quadratic?
Because the number is very, very small.
Very, very small. Take it out. And we know we don't do quadratics for the AP. So we should have x times 0.025 squared. All right. Now does it make it easier for you? Okay. Elizabeth, what'd you get?
6.4.
Do you have any units?